This
you, David,
conference will now be recorded.
And thank you for inviting me along today to talk around the work that we've been doing as part of Traction Decarbonisation Network Strategy and the work we've been doing in Network Rail as part of the path towards net zero carbon emissions for the economy. So as David said, I'm Stephen Hart, lead strategic planner within Network Rail's system operator function. So I work in the part of Network Rail that looks after strategic planning of the railway. So we look specifically at the next 30 years, 30 to 40 years in the railway and understand what needs to be done from a long-term planning perspective to be able to address the various different bits and pieces of things that need done. I work within the freight and national passenger operations part of system operator, which specifically looks at the strategic direction of the freight industry more than anything. But as freight is a network-wide entity, we also pick up anything that is deemed as network strategy, of which one piece is the traction decarbonisation work that I'm going to be talking through today. So just a quick summary of what we're going to be discussing today. I'm going to outline some of the challenges around decarbonisation and what the Traction Decarbonisation Network Strategy actually is. And then I'm going to talk around sort of how we went about doing it, what it says, and what we're kind of doing now and in the future off the back of the work that we presented. There'll be some opportunities for questions at the end. I'll rattle through the presentation and then we'll take questions at the end. If this was a face-to-face, I'd normally do questions in between, but it's a little easier if I just kind of go through and then we'll take questions at the end. But please do feel free to drop questions in the chat box as we go along, and it'll help facilitate the questions at the end. So the context of decarbonisation. So the UK passed the Climate Change Act in 2008 as a result of the various different climate action in a global sense at the time. And the Climate Change Act required the UK to legislatively have an 80% emissions reduction target from 1990 emissions levels. Since that was passed in 2008, the most notable event that happened was the Paris Climate Accord in 2015, which established the Paris Climate Agreement, where leaders of the world's countries came together to collectively commit the global nations of the world to keeping temperature rise on a global scale to below 2 degrees C, and to pursue efforts to limit that rise to below 1.5 degrees C. Since then, a lot of the organisations and countries in the world have gone away and tried to understand what that means and how that interprets for their own sovereignties and understand the implications that has on their wider economies and things. And as a result of that, there was a number of pieces of work done within the UK, which culminated with in May 2019 with a report from the Committee on Climate Change, who are an arm's length advisory body to the government around climate change issues, who ultimately concluded that in order for the UK to contribute towards its Paris Climate Agreement commitments, it needed to change the Climate Change Act emissions reduction target to net zero emissions by 2050, which means effectively we shouldn't be emitting any greenhouse gas emissions, and those emissions that we do emit should be being offset through carbon sinks. The government agreed with that ultimately, and in 2019 they made an amendment to the Climate Change Act, which so that the UK is now legally bound to reduce its greenhouse gas emissions to a net zero position by 2050. In the same time, as you can see on this slide as well, there's some interesting work being done in the rail sector as a whole, from the previous rail minister, Joe Johnson, who aspired to remove all diesel-only trains from the network by 2040, and the subsequent work that was undertaken as part of the Rail Industry Decarbonisation Task Force off the back of that. Ultimately, the TDNS work has come off the back of those previous research papers and the research that's been done as part of RSSB, and we'll be talking a lot more today around the work that TDNS has done off the back of that. Just to provide a little bit of context before we start going into the detail, rail as a whole is part of the surface transport sector from an emissions reporting perspective. The surface transport sector is now the highest greenhouse gas emitting sector of the UK economy. As you can see by the chart here, there's been significant progress made within the power sector and the industry sector as a whole. And as a result of surface transport emissions remaining broadly constant over the last 25 years, it's led to the place where surface transport is now the highest emitting sector. Transport emissions have broadly remained pretty consistent because although vehicles have been becoming progressively cleaner over that time, they've also been increasing in number as well, and those two factors have broadly balanced each other off. In terms of rail and rail's contribution into this, the rail network is part the railway is part of a group of different modes of transport that make up surface transport. Of that line that we saw on the previous graph, around 77% of those emissions come from cars and other small road vehicles such as bikes and vans and other bits and pieces. Around 3% comes from buses. 18% comes from heavy goods vehicles, so the lorries on the road basically, and 2% comes from rail. So out of that line that we saw on the previous slide, only 2% of that is the responsibility of rail. And from a surface transport emissions perspective, as you can see, rail is already a very green mode of transport and contributes very little to the overall emissions of the surface transport sector. But that doesn't mean that we can't do anything, and it doesn't mean that there's a need to sort of rest on our laurels with that. We'll see as we go through the presentation the role that rail has to play in supporting decarbonisation, as well as the need to decarbonise rail itself. But I'm here specifically today to talk to you around the Traction Decarbonisation Network strategy and the work that we've done in Network Rail and across the industry in providing and producing that document. So TDNS, as it's more commonly known, has principally been established to recommend which of three traction technologies, electric, battery and hydrogen, should be deployed where and when on the GB rail network in order to remove diesel trains and support the end of CO2 emissions from rail traction as a whole. In order to do that, we've built on the previous work that's been done, as I touched on, by the Rail Industry Decarbonisation Task Force and previous research work done by RSSB, which has concluded that these three technologies are the three technologies that will be sufficiently mature enough to be able to replace diesel traction. What we've done as part of TDNS is build and provide a programme business case in line with the HM Treasury's approved 5-case business case model. That's to allow us to talk about a number of factors. Normally in pieces of work like this, we would talk about the strategic need to do something and the economics that underpin it, so the costs and benefits that you get out of it. But a business case approach allows us to explore some of the slightly or more alternative areas, such as the kind of how you go about actually doing this, how you go about funding it, and the processes and practices that we need in place to be able to deliver such a significant programme of works as what we're doing. And the programme business case allows us to do that. When we initially started this piece of work 18 months ago, we were envisaging providing a submission at the end of October 2020. As we were going through the work, we were asked by both the Department for Transport and Network Rail's own executive leadership team to provide an earlier deliverable which we subsequently termed the interim programme business case. And that document was specifically provided to look at the strategic and economic aspects of traction decarbonisation, and was specifically provided to be able to support the department in the development of their transport decarbonisation plan, and also the work that Network Rail is doing as part of the whole industry strategic plan. So that addressed very much the end state and where we believed each of the three technologies should be deployed. And the focus of the programme business case, which was submitted at the end of October, was very much the kind of programme of introducing and implementing those recommendations that we made. The interim programme business case was subsequently made a publicly available document in September and can be found on Network Rail's website. The main reason why we're doing TDNS, why we've done TDNS and what it's there to do, there will be a lot of projects and programmes that will be required to deliver traction decarbonisation, and those projects and programmes all won't necessarily have strong economic rationale to do, but actually need to be done to be able to support the wider strategic goals of achieving net zero emissions by 2050. For those areas where they don't have a stronger economic case, the ability to have an overarching reference document to be able to point towards is a really, really powerful thing. So that is why we did the programme business case and why we've developed TDNS, to be able to provide that overarching frame of reference and strategic reference point for those projects and programmes that are actually developing and delivering the schemes to implement the recommendations that we've made. As well as that, there was a need to provide a much wider overarching strategic plan for not just Network Rail's own control period planning processes, but also for the wider industry and as part of wider industry business planning, from a manufacturer and rolling stock perspective, and also for those who are operating the network to understand what the network may look like from a traction perspective over the coming 20-30 years. That became especially key and especially important as it emerged that we would be moving towards longer concessions potentially as part of the forthcoming Williams review. So TDNS essentially has outlined the strategic rationale for why we should decarbonise traction and why we should remove diesel trains. And we've done that through focusing and outlining 6 key themes. Firstly, and as you would expect, most importantly, is the need to actually reduce direct emissions straight off. So both longer term emissions and removal of diesel and diesel traction emissions, and also the steps that we need to do to be able to remove those emissions and reduce those emissions in the short term through more efficient use of the assets that we have today. Secondly, as I touched on at the very start, the need to be able to support wider surface transport decarbonisation. With rail as a very green mode of transport already, we can support decarbonisation of surface transport and the wider economy as a whole through encouraging modal shift to rail of both passengers and goods. Those changes will provide not just carbon efficiencies and carbon benefits for the wider economy, but also provide a number of other benefits associated with modal shift across the wider transport sector. As well as that, there are a number of opportunities to be able to use rail to support with cross-modal sort of refueling and recharging hubs, and those could be used quite successfully to share the costs of technology and share the costs associated with traction types and fuel types, and be able to realise economies of scale. Traction decarbonisation within itself brings about a number of direct passenger and freight end user benefits. Non-diesel traction provides faster trains, improved journey times. Electric freight traction provides the ability to increase freight capacity as a whole, and the ability to be able to haul greater loads through the use of electric traction. As well as that, electric traction provides an improvement in reliability through the reduction of kind of moving parts within diesel as a result of moving away from diesel. And that reliability directly translates into the passengers and freight end users. There are a number of direct rail benefits, including direct operational cost savings, reductions in track access charges and fuel costs, which can directly support the wider industry. As well as that, there are a number of environmental benefits. The traction decarbonisation, whilst its principal aim is to decarbonise, as is the key in the title there, does provide a solution and offer a solution to improvements in air quality as well. Whilst a number of those issues are likely to need to be addressed in the very short term through other solutions away from the recommendations we've made as part of TDNS, the ability to deploy electrification, battery and hydrogen will solve the longer term and provide a longer term solution to air quality, especially for those areas where air quality is considered a lesser issue, such as in rural areas. As well as that, the delivery of traction decarbonisation will require a significant amount of infrastructure and rolling stock. That will be required mostly away from London and the southeast, and as a result there is a significant opportunity to provide long-term and stable employment and jobs away from that area, supporting and aligning with the wider levelling up agenda outlined by the government. As well as that, the opportunity to be able to build back better as a response to COVID and recovering the economy as we come out of the COVID crisis is a key, as part of the key government green agenda. Opportunities associated with the deployment of hydrogen offer a solution to provide first-in-class technology deployment of hydrogen vehicles in rail, where hydrogen is very much in its infancy in the economy. There will be a need for hydrogen, as was outlined earlier in the week by the Prime Minister, and it will be key that we can develop and deliver hydrogen solutions in rail early on to be able to support the wider economy as it transitions towards, as certain areas of the economy transition towards hydrogen operation. So why do we need to act now? So as I touched on earlier on, rail has a relatively small footprint, but is absolutely in a key position to be able to support surface transport decarbonisation as a whole, especially so for freight. A number of other sectors in the economy are absolutely going to struggle to get to zero. Aviation and agriculture certainly will be sectors where there is likely to be continued emissions beyond 2050. Those emissions are going to be offset through a national approach, but as it stands, there's currently significant uncertainty around the volume of emissions and the budget effectively that will be available to be sequestered. And it's likely that the complex sectors such as aviation and agriculture will take up most, if not all, of the budget available. That's going to mean many other sectors of the economy are going to have to reach zero, or certainly virtually zero emissions by 2050. For rail, that means that we'll need to deploy a significant amount of infrastructure and rolling stock, and that will require a significant plan, a long-term plan to develop and deliver. And we need to begin to undertake that work now so that we can start to deliver that in an efficient way as possible. As well as that, we have a number of proof of concept vehicles that exist for battery and hydrogen today, and we need to enter those into operational service so that we can begin to understand and embed the operational lessons associated with those vehicles, and we can embed those into future developments and deployments as we move forward. So TDNS and what TDNS has done. As I've touched on as part of our analysis already, TDNS has very much taken a focus from the technical work that's been developed previously through RSSB and the Rail Industry Decarbonisation Task Force. That work clearly identified that for passenger operations over 100 miles an hour and for freight services, that the only credible technology to deploy to decarbonise is electrification. Therefore, for areas of the network where there are high freight volumes and operations that exceed 100 miles an hour, we've proposed electrification as the solution. Equally, electrification has a relatively high capital cost compared to battery and hydrogen, And for areas of the network where there's reduced usages and lower usage, it's unlikely that electrification is going to make economically viable sense to deploy. As such, based around the technological capabilities of those traction technologies, we've allocated those areas of the network to battery and hydrogen. That leaves a number of areas of the network where there isn't a technical need to deploy a specific traction technology, but actually as a result of interfacing with other areas of the network or through higher intensity of use, there may be benefits of deploying one technology over another. And we've deemed those multiple option solutions where you could deploy any of the traction technologies, but actually you may want to sort of pick one based on its economic or operational reasons. Overall, the analysis that we've done was done using the decision tree that I've just talked through there, and you can see on the slide. And as a result of that analysis and that approach, what you end up with is of the 15,500 single track kilometres of unelectrified railway on the GB network, you end up electrifying around 11,500 of them, with around 400 operations of battery over 400 single track kilometres and 900 for hydrogen. You end up with 2,300 single track kilometres where there isn't a clear technical choice to be able to deploy, and in theory you could deploy any of the traction solutions. We've undertaken a number of areas of further analysis using economic modelling and operational modelling, and determined that of that 2,300 single track kilometres, we believe there's an extra 1,300 single track kilometres of electrification required, and a further operation of over 400 single track kilometres for both battery and hydrogen. Ultimately, out of the 15,500, we've ended up with 260 single track kilometres where we have not made a decision at this stage because further work is required before a decision can be made. What we've done is map that out and map out what that looks like, and you can see an extract of the map on the right hand side of this slide to show which technology should be deployed where. Further information about all of this and the various different recommendations that we've made can be found within the interim programme business case, and a much more detailed breakdown of this map's included in there as well. And I won't labour too much on that as part of this slide. Just a point of note, we did also make a number of other recommendations away from which technologies to deploy where. Specifically, we identified that for those areas of the network which are being sort of reopened or focused upon to reintroduce rail services, any proposed new railways should consider how they will interface with the wider network that we've proposed as part of TDNS, and what role they will play in a zero carbon network going forward. As well as that, as I touched on earlier on, we have battery and hydrogen rolling stock that is as a proof of concept stage. We need to begin to introduce those services into operational deployment so that we can learn lessons from their operational deployment and ensure that those are learned and embedded into future deployments of battery and hydrogen trains as we move forward. There will definitely be a role for diesel as we transition towards a net zero railway. Diesel and diesel hybrid trains will be key in ensuring that we can efficiently reduce and remove as much of our emissions as possible in an optimum way and as quickly as possible through the use of the likes of hybridization and using alternative fuels in those trains to make sure that we're getting the best asset life out of them as possible. Diesel is absolutely not a solution for the end state, but will be absolutely key as we progress forward through decarbonising the wider network. As I touched on earlier on, modal shift is going to be absolutely essential, and we need to continue to support programmes and projects within the rail sector that encourage modal shift to rail and provide capacity enhancements and capacity increases to allow us to be able to accommodate the growth forecasts, albeit the pre-COVID growth forecasts, but certainly the long-term projections of passenger and freight operation on our railway. As you can see, and as we've talked through there's a significant programme of electrification. Electrification is a major backbone and a major key part of the recommendations that we've made, but it's not going to be able to be delivered overnight. We need to ensure that we're delivering this programme as efficiently as possible, and that will take time. We need to ensure that there's consistency and lessons learned from the previous electrification schemes that we've deployed, and we need to ensure that the delivery of this is sort of in a progressive manner and a steady state to allow the supply chain to be able to be optimised and efficient delivery to be realised. Equally, for some areas of the network where electrification will be delivered at a much later stage in the programme, we may need interim solutions of hydrogen or other zero carbon rolling stock to be able to accommodate and reduce emissions in the very short term. So that's the recommendations, and that's what TDNS says. What we have done as part of the business case is we've undertaken some economic modelling as well to determine exactly kind of the costs and benefits associated with that, and whether or not it's worth investing in in its own right. So we've talked through the decision tree analysis already and how we've made those decisions around infrastructure and infrastructure deployment. We've used that infrastructure output that we've just seen there to be able to determine and influence the service changes that need to happen and how we transition services away from diesel operation into the zero carbon traction mode. Those two phases combined allowed us to be able to define a number of economic parameters that we could then model so that we could undertake economic analysis. We've also defined a number of pathways, a number of different ways of getting to an end state, and a number of different end states depending on kind of the ask. That's been done specifically to be able to provide a suite of options to government to be able to take forward and consider as they choose the approach and how far and how fast we go with traction decarbonisation, balancing that off with the investment needs of the wider economy. Overall, all costs and benefits have been included, including the capital costs of electrification, battery and hydrogen, and also the costs around infrastructure renewal, maintenance, disruption, rolling stock, etc., etc. From a benefits perspective, we've principally focused around CO2 emissions, but as I touched on with electric trains providing improved journey times and more reliability, we also captured a number of benefits associated with that as well. That's all been sort of recorded and documented within the interim programme business case, and I've extracted a few charts here just to be able to talk around some of the key points. As you can see, we defined a number of pathways that get us to different places at different stages in time. We've done that specifically to understand the relationships between kind of the ambitions, or how far you want to go, and speed, how quickly you want to get there. We've also modelled based around the carbon budget periods to allow this work to be able to interface and align with wider carbon budgeting that's been done across the wider economy. As you can see, the graph on the right here shows what the emissions trajectory profile looks like, and provides ultimately an envelope for kind of a decarbonisation of traction within the railway, to a stage where you get to sort of 80–90% emissions reduction, down to virtually zero emissions reduction for the remaining pathways. As you can see by the chart on the right hand side, from an economic appraisal perspective, we've used something called net present value. That's effectively a sum that takes all of the costs that you incur and subtracts all of the benefits that you incur to define kind of whether or not you effectively get more back in benefit out of the investment than you invest up front. We've obviously modelled a number of different capital expenditure approaches to reflect the kind of uncertainty around the cost of electrification on the whole. As such, we modelled a low capital expenditure profile and a higher capital expenditure profile. As you can see, what's happened is you effectively end up with a balanced business case that's effectively broadly cost neutral. So the low capital expenditures lead you to having a return on your investment. The higher capital expenditures lead you to not getting back the money that you invested. And that leads to a broadly zero position. So effectively what that means is for every pound that you invest, you get a pound back in return over the appraisal period that we've considered for traction decarbonisation as a whole. So that marks the interim programme business case and what's published on Network Rail's website today effectively. What I'd like to do now is just briefly outline where we're going, what we've considered as part of the further developments and further submissions, and the kind of direction that that's taken us in. So those pathways that we've just talked about there were predicated on kind of high-level indicative programs that were developed by me and my team as a response to kind of engaging with the industry. But those programs themselves were not actually validated or overseen or didn't have any direct industry input into them. As a result, what we've done is the next stage, we've refined the programs that we've used to model, and we've ensured that we've ensured that the programs that we've used to model are based around industry input. So we've engaged strongly across the industry to be able to consider and get a number of stakeholder inputs into reprofiling and redesigning what that program to delivery looks like. As well as that, we've engaged heavily with the supply chain through our relationship with the Rail Industry Association, and we undertook a market sounding exercise as part of this stage of the work to be able to define and get direct market input into the shape and structure of how that programme could look. We've effectively used that redefined programme to then be able to update our economic modelling. What we've done is define two new pathways, so a pathway that gets us to 97% of reduction by 2050 and one that gets us there by 2055. We've used the programme that we've developed with the industry and the supply chain to model what that looks like and update the economic analysis accordingly. What we've also done is modelled a number of interim solutions in that as well. I touched earlier on those areas of the programme that will be towards the back end may benefit from interim solutions of hydrogen rolling stock. Within our programme, for those areas that are towards the back end, we've identified a number of areas where hydrogen rolling stock could be deployed today to be able to support the decarbonisation of those aspects until electrification is delivered in the future. As well as that, with further information that we've received from RSSB and the intermediary time between the interim programme business case and now, we've also been able to model some air quality benefits as associated with the work that we've recommended as part of TDNS, and also some freight operational benefits as well. And those benefits have been added into the business case. Ultimately, the programme business case takes what we did in the interim programme business case, which was paint the end state picture of what the network needs to look like, and to take that one step further and define the journey that we need to take to get there, very much providing the when and through providing a kind of prioritised programme to be able to deliver the recommendations that we're making. What that does is allocates the schemes to tranches of delivery, which are broadly aligned to the carbon reporting periods that we saw in the earlier slides. As I've touched on, that programme has very much been built on with the support of the wider industry. We've engaged with a huge number of organisations across the whole of the TDNS piece, but also most recently to be able to support and define what that programme delivery looks like and the recommendations that we've made, so that we can capture as much stakeholder priority as possible within the programme that we've modelled. As I touched on, that programme has then helped us to identify areas for interim solutions, which may be able to be used until full electrification can be delivered. And the analysis has identified that those interim solutions do bring about additional benefit if we act quickly and introduce those services quickly. Ultimately, those outputs and those areas that we focused on and talked on there have been used to update that economic modelling and be able to discuss that and present that, and that's been included within the programme business case, which was successfully delivered to the FT, Transport Scotland, Welsh Government and the TDNS programme board that's overseeing the piece of work at the end of October. So I appreciate that's a lot of information. I've gone through quite a lot of stuff there. I've seen that there's some questions in the chat, which is always good to see. I'm sure there'll be plenty more questions in the chat to discuss and talk about as well. The one thing that I would like to say is that this has been a huge industry effort. we've seen a significant amount of engagement from across the wider industry to be able to deliver this, and this very much has represented and presented an industry view of traction decarbonisation, not just Network Rail's view. Although we've held the pen on this and we've written this, we've done so in strong collaboration with the vast industry that we operate within, and this does have broad cross-industry support in terms of it. We now need to take the work that we've done as part of the programme business case and actually be able to begin to translate and transition that into meaningful schemes where we can begin to develop and deliver electrification and the deployment of battery and hydrogen rolling stock, so that we can start on this journey as soon as possible to be able to support the wider economy and transition towards zero carbon. Thank you. I hope you found that useful. These slides will be shared. There's links to the interim programme business case and executive summary on that final slide there, and my email address is on there if anybody has any specific questions that they'd like to follow up on as well, if we don't address those within the session. And I think I'll pass back to Dave, who is hopefully going to act as quizmaster and challenge me with some very, very interesting questions, I'm sure. So I'll pass back over to you, David.
Okay, thank you very much, Stephen. Yeah, we have got some questions that come through, so we'll just work through those one at a time, if that's okay, and I'll do my best to convey them. So the first one's from Jonathan Seekins. Hi, Stephen. Do the emissions produced from maintenance and renewals get factored into the contribution to rail's overall emissions?
So that's an interesting question. The vast majority of our emissions within Network Rail are principally focused around two key areas: direct traction emissions, so emissions that come from trains directly, but also from kind of the supply chain and the embodied carbon that's operated within the wider supply chain sector. And then there are other direct emissions from rail that aren't direct emissions from sort of Network Rail and the wider organisations that make up rail that are also included. In terms of our analysis and our work, we've specifically focused on tailpipe emissions or direct emissions to be able to kind of provide a definitive point there. The one thing that I would say is certainly from an embodied carbon perspective, whilst there's lots of very good evidence from the various tools that exist, most notably the rail carbon tool that's provided by RSSB for rail infrastructure, that doesn't extend to other areas of the industry such as rolling stock, battery infrastructure, hydrogen infrastructure, and other areas. So it's quite difficult to get a full picture. We kind of can see what some of that looks like, but there is much more further work needed across the wider industry to be able to understand how that bigger picture plays out and what role we have to play in that kind of bigger picture of embodied carbon from a whole systems perspective.
Okay, thank you. I think there's similar questions to that later on, but we'll so Vladimir's come with a question: is there a global or regional system that looks together at the rail lorry business systems to provide global supply for hydrogen or battery charging? For example, make wider economy from scale, strategic view, so to speak. So I think this is kind of looking at how all the systems work together.
Yeah, so there's lots of things that are packed in that question that I could probably fill an entire session talking about, really. But certainly from a cross transport perspective for battery and hydrogen, there's been a lot of focus recently across the wider transport sector at focusing on kind of combined recharging and refueling hubs, and I touched on that during the presentation a little bit. There's lots of very good work that's being done across the transport sector to understand how that can play out and the roles that can play. And obviously the Prime Minister recently acknowledged and announced the investments that are being proposed for the wider hydrogen economy and how that can support the wider transport sector as a whole. From a joined up approach, DfT are obviously providing the transport decarbonisation plan, which is looking at cross-transport decarbonisation and understanding what needs to be done in the wider transport sector as a whole. And that will be a fantastic step in the right direction in terms of decarbonising the wider transport sector. There are obviously significant opportunities for rail to play, especially in decarbonising the likes of heavy goods vehicles and freight, as there isn't credible alternatives for zero carbon HGVs as it stands. And in theory, the only way that you can move logistics zero carbon with zero carbon is through rail effectively, and using electric freight traction to be able to do that. That's obviously a bit of a moving beast. Technology moves on, technology advances, and there are emerging HGVs and emerging technologies, including wiring motorways, which could support with decarbonising HGVs and HGV traffic. And I think we just need to be cognizant of that, but we need to ensure that rail has a much bigger role to play in the logistics sector if we're going to decarbonise the wider logistics of the UK.
Well, thank you. Next one is from Peter Hallowell. He's touched on the hydrogen. So how does hydrogen traction power operate? What facilities and how are they provided for?
So I'm not an engineer. I'm nowhere near a hydrogen rolling stock engineering expert. So the answer that I provide will be my very high level understanding of how it works. Effectively, hydrogen is created through electrolysis of water. So effectively, you split water into hydrogen and oxygen, and hydrogen is then stored. You then undo that process through a chemical reaction effectively, and that by undoing that process you release energy, and that energy is then stored in a battery that then drives an electric train effectively, and that tends to be known as hydrogen fuel cells. The methodology that's done. I understand that you can combust hydrogen as well, but the technology of the day appears to favour fuel cells over direct combustion. In terms of the infrastructure needed, you obviously need to be able to electrolyse water into hydrogen and oxygen, and that requires power within itself. Green hydrogen, as it's termed, is using electricity that's come from renewable energy sources, so through a windmill, basically, to be able to do that. There are varying grades of hydrogen where you use grid mix electricity to be able to do that, and other stuff. But the green approach is to use renewable energy to do that. You obviously then need to be able to store the fuel somewhere on a depot, and then you obviously need to be able to fuel that fuel into a train, and then the train system itself. Hydrogen's not a massively energy dense fuel. For every 1 drop of diesel that you have, to get the same amount of energy, you need 7 to 8 drops of hydrogen. So as you can expect, the diesel capacity tanks that you would have, the tanks need to be significantly bigger to be able to accommodate and do the same sort of thing as diesel. And as a result of that, that takes space. And in our network, space normally means that you have to eat up something because of our gauge constraints. And as you've probably seen through the recent demonstrator that was provided by Paul, a lot of the equipment is currently located within the cabs, although I believe there is aspiration to take that under the train, but that will limit the volume of hydrogen fuel you can carry.
There's a question from Abigail, and I have noted that she said she wasn't able to hear before, but hopefully that's been rectified. But and please forgive me, has capital carbon been accounted for in the solutions provided? And I don't know what capital carbon actually means, so that's how naive I am.
So I think by capital carbon we mean kind of carbon that's embodied and carbon that emerges from the construction process. We, as I touched on earlier on, we haven't accounted for that within TDNS. We've identified it as an issue and identified it as something that needs consideration, but without having fuller data sets around the embodied carbon values of rolling stock and battery and hydrogen infrastructure and things like batteries themselves. It's difficult to provide a kind of a well-rounded view that doesn't effectively look bad on electrification, because there is obviously a volume of embodied carbon associated with the delivery of steel and concrete associated with electrification. There is a number in TDNS for what that looks like. I think the analysis suggests that if you were to do all of the electrification that we provide, that we've recommended within TDNS, you end up with broadly the annual emissions of the entire rail sector as your embodied carbon value. It's about 1.8 billion kilograms.
Okay, I might just bear in mind timescales, and like you said, a few questions that have come through here, Stephen. So I might premise a couple of them. I think Jacob Cooper sent one across. I think overarching, if I can summarise, it's talking about we've completed or about to complete lots of electrification programs. Is there a risk of losing skills across the supply chain? When will funds be kind of released for forthcoming electrification programs, especially aligned with what you presented before, kind of miles of single track that needs to be electrified?
Yeah, absolutely. So there's potentially a significant program of electrification as I've presented there, and as you've rightly noted, there's a number of electrification schemes that are either closing or coming towards the end of delivery. If we're going to achieve this, we absolutely need to maintain and retain as much skill as possible, and the Rail Industry Association have been very vocal around this, and we've been working closely with both them and government to understand and be able to support in defining what that might look like. TDNS obviously provides a very long-term, potentially very stable program of electrification delivery over at least the next 30 years. And that could be absolutely critical in ensuring that we grow and make our electrification industry and supply chain within the UK sustainable for a long period of time. And that is going to be absolutely critical. There are obvious challenges, obviously the current crisis and the impact that has on financial decisions that are being made by government and UK Treasury is going to be key. And there is definite commitment, as we've seen earlier on from Prime Minister and from the Treasury this week already. There is a definite commitment to climate change and global warming, and there is a definite desire to ensure that rail and rail electrification plays a key part in that. So I think the message has definitely landed there. And I think it's a case of watch this space for the projects and programs to follow up on that. But it is absolutely key that we ensure that the skills that we've developed over the previous control period and the lessons that we've learned and embedded within our schemes continues to be done so as we move forward with a much longer term sustainable program.
Okay, there are some more questions in there. We'll probably come towards the end of the session now. So I'd just like to thank you, Stephen, for taking your time to present to us today. It feels as if we could ask you more and more questions for an hour or so and be educated suitably. So really do appreciate your time today. And I don't know if people who are still with us, if you could unmute yourselves, and we'll just give you a round of applause. So thanks again for presenting today. Thank you very much.
No worries, thank you.
Yeah. So the presentation, I think, will be uploaded onto on the Network Rail YouTube site, so that will be a useful reference point for everyone as well. Thanks for joining us today, and hopefully everyone's safe and looks after themselves. Thank you.